Joint and combined variation. Our objectives at the end of this presentation should be able to define joint and combined variation, illustrate situations that involve joint and combined variations, translate into joint and combined variation statement of relationship between two quantities, and solve problems involving joint and combined variation. Let's start. What is joint and combined variation? Remember that variation may involve two or more variables. If a certain variable varies directly as the product of two other variables, then it is said to be a joint variation. Otherwise, if a certain variable both jointly as the product of two variables and inversely as the other variable, then it is a combined variation. Here are examples of a joint and combined variation. For the first example, A varies jointly as x and y. The keyword we have is varies jointly. That's why we can write this as A varies jointly as x and y. So A is equal to kxy. Second example, T varies jointly as A, B, and C. Again, we have the word jointly, therefore we'll be using a joint variation. That's why we have T is equal to K, A, B, C. Remember that in a variation, we should have a constant of variation, which is K. For number 3 example, W varies directly as X and inversely as Y. This is an example of a combined variation. By its word combined, meaning this is a combination of two different variations. Remember that in a combined variation, the combination can be a direct linear variation and an inverse variation. Another combination is direct square variation and inverse variation. And the third is joint variation and inverse variation. For number 3 example, W varies directly as X and inversely as Y. We can write this as W equals Kx all over Y. Number 4 example, P varies directly as the square of Q and inversely as the cube of R. So this is an example of a direct square variation and an inverse variation. So as P varies directly as the square of Q and inversely as the cube of R. So we have P is equal to Q squared over R cubed. The last example, R is jointly as M, N, and P and inversely as A, is an example of a joint variation combined with an inverse variation. So as R jointly varies jointly as M, N, and P and inversely as A. So we can write this in mathematical equation as R is equal to K, M, and P over A. Let's have example number 2. If Z varies jointly as X and Y, and Z is equal to 60 when X equals to 12 and Y equal to 10, find Z when X equals to 14 and Y equals to 14. Now remember, just like in other variation, we need to translate the given statement into mathematical equation. So as Z varies jointly as X and Y, we can write this as Z varies jointly as X and Y. How to identify for the value of K? To find K, just simply divide both sides of the equation whatever variable that K has. So in this case, XY is with K. So I will be dividing K both sides by XY so that we can eliminate XY, and what left in one side of your equation is the variable K. So we have K is equal to Z over XY. Now, we already know the formula for finding for the K. we can now find for the value of k by the given values of z, x, and y. So for the value of z, we have 60. For the value of x, we have 12. And for the value of y, we have 10. Let's substitute the given value to our formula, which is k is equal to z over xy. So we have k is equal to 60 over 12 multiplied by 10. We have now 60, k is equal to 60 over 12 times 10 is 120. Then get the lowest term. 60 over 120 is 1 half. Therefore, k is equal to 1 half. After getting the value of k, we can now substitute the given value of k to our original mathematical equation, which is z is equal to kxy. So we have z is equal to 1 half xy. This is now our equation of the variation. After getting the equation of the variation, we can now proceed in finding z when x is 14 and y is 14. So substitute the values of x and y. So z is equal to 1 half times 14 times 14. So just multiply the numerator to the given values of x and y. So we have 1 times 14 is 14. 14 times 14 is 196. And then, divide it by the denominator, which is 2. Divide 196 by 2 will give us a quotient of 98. Therefore, when x is 14 and y is 14, z is equal to 98. Example number 3. If z varies jointly as x and y and inversely as the square root of r, and z is equal to 28 when x equals to 14, y equals to 6, and r equals to 9, find z when x is 12, y is 15, and r equals 36. So this example is an example of a combined variation, a combination of a joint variation and an inverse variation. So let's translate first the given statement z varies jointly as x and y and inversely as the square root of r. So we can write this as z varies jointly as x and y and inversely as the square root of r. Now, how to find for the value of k? So let's have z equals kxy over square root of r. So to find for the value of k, the first thing we should do is to eliminate the denominator. So to eliminate the denominator, we will just simply multiply both sides of whatever the denominator is. In this case, the denominator is square root of r, so I will be multiplying both sides of the equation by square root of r. So square root of r here will be cancelled out, and then let's multiply square root of r times z. Square root of r times z is z square root of r. Then just simply copy k equals xy. Next step is we want to eliminate the xy since we only want to find for the value of k. So to eliminate xy, we will be just simply dividing both sides of the equation by xy. So this will be cancelled out. Therefore, k is equal to z square root of r over xy. Since you already know the formula for getting k, we can now proceed on finding for the value of k. So, the given are, say equals 28, x equals to 14, y equals to 6, and r equals to 9. So, let's substitute by the given value. So, we have k is equal to 28 square root of 9 over 14 multiplied by 6. Now, let's first get the square root of 9. So we have 28 times the square root of 9, which is 3. Multiplying 14 by 6 will give us a product of 84. Next is let's multiply the numerator. We have 28 times 3, we have 84. Now 84 over 84 is equal to 1. Therefore, the value of k is 1. Next, let's find for the equation of the variation by simply substituting value of k, which is 1. So since our k is 1, no need to write 1. Therefore, our equation of the variation will be z is equal to xy over square root of r. Now let's substitute by the given values. Z is equal to 12 times 15 over square root of 36. Let's multiply 12 by 15. Multiplying 12 by 15 will give us a product of 180. Now get the square root of 36. The square root of 36 is 6. Then, the next step is to divide 180 by 6. Dividing 180 by 6 will give us a quotient of 30. Therefore, z is equal to 30 when x is 12, y is 15, and r equals 36. Thank you!